The Daily Exchange, guys, we're here, Consensus, with Adam back from Blockstream. Obviously, we're talking all the thing about Bitcoin. I'll see you guys right after this. All right, guys, we're back here with Adam back from, I guess, the CEO and co-founder of Blockstream.
That's right.
Welcome to the Daily Exchange.
Thanks for having me on.
Now, tell us, Adam, how did you get first involved with Bitcoin?
Well, I've been interested in electronic cash and privacy tech for a really, really long time. So I was interested in PGP and anonymous remailers and things related to Tor before Tor was around. I worked for a startup in Canada that was trying to build a Tor-like privacy network for web browsing. And before that, when people were working with remailers, one of the problems was the infrastructure is all provided by volunteers. There's no way to pay, and so if you want to charge for the service or find a way to fund it, you'd have to pay with credit cards, right? And then you would lose the privacy, so there'd be no point. So it was clear to people that you really needed anonymous bearer eCash, and that's what people were very excited about as a kind of holy grail privacy application. So a lot of people, on cryptography, on the cypherpunks list, spent time from like early to mid 90s onwards thinking about how to make this work. And there was a previous system called DigiCash with some cryptography invented by David TRON. And it was a kind of centralized system, and the only way to get coins was to buy them, basically. So they tried to partner with banks, and actually they didn't try to run an experiment, but the cypherpunks tried to run an experiment, which is that to encourage people to use their system, they said they would run a demo server for the foreseeable future, and they would hand out coins just for emailing them. And they said there would be never more than a certain number. I think it was like 1 million of them. And so people on the cypherpunks list thought it'd be fun to try and create a value for this, because they're just demo coins, right? But we figured if they're limited, scarce, we could create a value by selling things for them. So we started to sell like t-shirts and like different stuff online. And before that experiment really got enough momentum to actually hold a price kind of thing, the company went bankrupt. And the double spent database, which was centralized, went offline. And so whoever had coins, you couldn't really tell whether they were spent or not anymore. So it kind of showed people the risks of single point of failure centralized systems. So after that, there was a lot of discussion about how to make it decentralized. And so in 97, I came up with the hashcash idea, which is really about controlling spam, particularly when it was sent through remailers, because you couldn't block the IP address, you couldn't block the sender's email address, because you didn't know what it was by design, right? And so it occurred to me that what was the fundamental problem is that it's free. So I tried to find a way to create a cost that wasn't credit cards. And so it's easier to create a cost than it is to pay. So I found a way to create a postage stamp, like an electronic postage stamp, which you created by running your CPU very hard for a few minutes. And the difficulty was tuned so that it would take a couple of minutes on a typical desktop CPU. And so that got integrated into some of the remailer software, into Spam Assassin and different things. But almost immediately after that was discussed on the cypherpunks list, people started to sort of make observations that it seemed like digital gold, and then try to wonder how you would sort of have a stable price and a stable supply, because it's kind of free for all, right? If there's a difficulty, like you have to make a 20-bit collisions, like 20 zeros, and it takes a couple of minutes to make one of those, and it's worth money, then everybody's going to go nuts and they're going to create billions of them and you're going to get hyperinflation. So it wasn't clear how you would control that. So that was a discussion really, that how would you control inflation in this situation? And a couple of people had ideas. So Nick Szabo had an idea called BitGold, which involved a kind of specialized market activity to create a stable bundle of stamps of standardized value, even though there's different scarcity. And Wei Dai had another idea, which he called B-Money, which was to have a kind of federation of servers who were engaging in some kind of market estimation and difficulty setting periodically, like once a month or something like that. So those didn't get implemented. How Finney, and the idea of how you would create those coins was you'd mine them with hashcash.
Right.
And later in 2098 and later in 2004, Hal Finney built another system which was also using hashcash for mining, but his system was centralized and using trusted computing platform, so secure hardware that you couldn't tamper with the software once it was loaded. And the idea was you would do some mining, create a coin, send it to the server, and it would issue you with a TRON coin. And because of the security, you'd get a signature on the code, and you'd know that the server didn't cheat because the operator of the server couldn't tamper with it. And it didn't really try to get a price, it was more like a technical experiment. Anyway, so I think that was the last kind of big design variant or something that got implemented or built before Bitcoin came onto the scene. So, and I mean, I did a few other things related to electronic cash. So I implemented in a library CHORM and Brand's electronic cash protocols sometime in the early 2000s as well.
And so, this is an interesting question that everyone's pondered. Do you know who do you think Satoshi is?
I don't know. So on the cypherpunks list, because the people were interested in privacy technology, and some of the participants were running remailers, operating remailers. I operated one for myself for a while. Some of them would practice what they preach and use remailers, so that there would be like very technical discussions about cryptography and how to make electronic cash work and what the kind of technical limits or hurdles have to be overcome. And some of the participants were anonymous, so even then you wouldn't know who was saying what. And actually there was another kind of prototype electronic cash system implemented called Magic Money, and the author of that was Product Cipher, obviously another pseudonym, right? And there was another piece of software implemented called PGP Stealth, which was a sort of steganography add-on to PGP, and that was implemented by Henry Haster, which is another pseudonym. I presume it's like a literary reference. So there's a bit of a tradition of anonymous participation and pseudonymous software authorship going on there over the years. So it's possible that Satoshi was one of these anonymous participants, or one of the existing ones choosing a new name, or somebody with a name who chose a pseudonym. But it's also possible that it was somebody who looked at a problem afresh, because as you saw, there were lots of people who, when they saw hashcash, it triggered them to think about, it seemed to lead to the thought that this is like digital scarcity, digital gold, and then onwards, well, how do you make it respendable? And then there are a range of problems. So a lot of the problems were already understood and outlined. So the discussion from Nick Szabo involved Byzantine generals problem, consensus protocols, and smart contracts was an even older idea, actually, also a Nick Szabo idea. So, a lot of the outline ideas were there, but there were gaps about how to control inflation and supply, and Satoshi solved that, plus made it work in a completed system, right? So, it's not clear if it was somebody from that list or if it's somebody who hit the same ideas.
Do you have an instinct?
Not really. I mean, when I first, I do think it's like to be one person and not a group of people, because, it's it's difficult to hold a secret if many people are involved, and because the sort of continuity and code style and writing style and so on, it looks like all one person doing things, and also it's just generally, it just seems like something that one person would do to me, and it didn't occur to me actually when I received emails early on about, Bitcoin in development and like a draft of a paper, that Satoshi Nakamoto was a pseudonym. I just thought, it's just another email. Because if you have like open source software or like technical reports or papers online, once in a while you will get an email, saying that they've cited your paper or asking a question about it because they're using it in something. And so it seemed, to me, it just was like another email like that. And so I responded and, pointed at B-Money. So one of the things to notice is that it seemed like he didn't know about B-Money. And B-Money wasn't very widely known because it was just posted, it was just a blog post or like a text document on a web, and it was only really discussed on the cypherpunk list. So probably only a few hundred people were paying much attention, and we thought it was a cool, design outline, but it probably wasn't that widely known by, for example, academics or people who weren't on the list. So whether there's a question is like, well, if he was on the list, how comes he didn't know about B-Money? But maybe he was pretending, right? Because if you cite too many very niche specific things, it would kind of like pigeonhole you. So we don't know. I mean, the other thing is, it was, as I understand it, the original version is implemented in Windows, which is also kind of atypical. Most of the sort of applied crypto and networking programmers, open source ones, tend to work on Linux. So that's also kind of unusual.
Okay. And in terms of right now, I guess, there's a lot of interest in big blocks. And what do you think about big blocks? Do you think Bitcoin should move to big blocks?
So I kind of felt like I was a bit in the middle on this conversation when it erupted, because it was a few years ago now. Because I think it's a kind of trade-off, right? So and there was a series of conferences on this topic, scaling Bitcoin conferences, and at the first conference, which was in Montreal, probably in 2015. I'm not actually sure the date, but Dreiger and Poon, the Lightning authors, drew a graph to explain the trade-off, and they called it the bathtub curve. So basically, they were saying if the blocks, so it's sort of about decentralization. So Bitcoin relies on decentralization to guarantee fungibility and censorship resistance, so that there are enough different miners that somebody will process your transaction. If you don't, and that the cost of verifying is reasonable enough that enough users are able to check it, because if nobody can check it, you don't know what's going on, kind of thing. So they were arguing that if the blocks are too big, then you get worse decentralization because fewer people can check it. But if it's too small, you get a different type of loss of decentralization, which is very few people can use it, right? So it can provide service to some people who can pay the fees involved, but that's not very decentralized. Like, we want to see lots of people using it too. So that was the kind of graph, and it's a trade-off, right? So, you could say that there are arguments to be made, and Luke Dasher makes them, that things are already quite heavy. And if you try running a full node on like a reasonably high-end laptop with an SSD, it sure takes a while and chews up your CPU to sync it. So the initial download is pretty heavy, and the CPU hit is pretty heavy. And if you end up having to re-index it, so if you turn on the transaction indexing, which is needed for some use cases, that takes hours. And like if you have to re-index, it takes hours. And it's also, it's using different resources, right? So it's using a disk, so it's I think it's over 220 gigabytes now. So this disk storage, people say disk is cheap, but I think that's generally true. And then there's the bandwidth component. So, you can run into bandwidth caps for people even in developed countries, as well as the CPU cost. And there's another one, which is the memory. So in order for wallets to be responsive, so that when you go to spend a coin and look at the details, for it to load up quickly and react quickly, it has to find the transaction out of this 220 gigabytes. And so there's the unspent transactions, which is a couple of gigabytes. And when you have things in memory, they tend to use up more space because you've got pointers and data structures. And so you want a fast lookup mechanism. And I think that tends to sometimes get too big for memory, but you cache it or you make an index in memory. And so, if things get too big, you can kind of have, if you miss memory and you go to disk, then everything, slows down enormously. So there are all kinds of trade-offs and bottlenecks. So, I wouldn't say there's really a right size, like you could say, well, it's already too big because look how slow and annoying it is to sync nodes. Or like the performance characteristics of the machines are kind of high. So some people will say, well, you can buy a faster machine for like, X $1,000, and that's true. But we also want Bitcoin to be usable by lots of people. We want people to be able to use smartphones for some parts of it. And so, actually the Bitcoin satellite service, we put up a network of Bitcoin satellites by leasing bandwidth on 4 satellites, and more recently there's coverage now over Asia and Pacific, so over Australia particularly, and it saves you like 10 gigs or so a month, right, of bandwidth because you're receiving all the transactions in the blocks and stuff like that. So that's a way to take one of the costs out, because on a cost basis, to run a full node, generally not a big deal. People in developed countries with high-speed internet, but in emerging markets like in Africa and India and different places, sometimes high-speed internet is expensive, and on top of it being expensive, like literally costs more than let's say in the US or Australia, their income is lower too. So enough bandwidth to directly participate in the Bitcoin network becomes too much. So another way to scale is to have different layers. So if you have a single layer, then people with different use cases and different cost sensitivity, different access to bandwidth are competing for the same resource. And in that environment, the people who are less price sensitive tend to sort of degrade the performance for other people. So like particularly in a price run up like we've seen in the last week, the traders get in a trading frenzy, right? And they want to make fast trades, they want to be the next block, and they overpay. And so one way that network protocols tend to evolve with like TCP/IP is there are different layers specialized to different use cases. There's the IP layer, and then there are TCP/IP, which is also pretty low level. And then you've got like web and VoIP things which are using UDP for lower latency but lose data. So all these different kind of trade-offs in peer-to-peer networks and unicast, multicast. So you see that with evolving now in the Bitcoin space, where you've got Lightning, which doesn't provide as robust cold storage, for example. It has some hot wallet exposure, it has some reactive security, like you need to monitor or have somebody else monitor for you, but it can scale much better, right? And so that's a kind of retail fast payment where you don't want to wait around for transactions to confirm. And I think it's probably best for like medium-sized payments, like small to medium. So what you would feel comfortable storing on a smartphone. And
it's like petty cash.
Yeah, well, petty cash was Russell's project. I don't know if you know that, but Rusty Russell is a Linux kernel developer. He lives in Adelaide. He's been working on Linux kernel for like over a decade, and he did a lot of the Linux TCP/IP implementation and firewall and different parts of that. But anyway, he got interested in Bitcoin and started trying to experiment with how to scale Bitcoin using sharding. So he made a coin called Pettycoin. And then around that time, the Lightning network idea arose. And so we persuaded him to come and work for Blockstream and head up our Lightning development. So we have like 3 people working full-time on Lightning and somebody else working on applications and other parts of Lightning. So that's pretty cool. So that's like sharding is another approach, but it makes trade-offs. So I think Rusty considered Lightning to be an even more promising way to scale. And another direction you can have layers is things like Liquid, which is a sidechain. And that particular instance of a sidechain is optimized for exchange traders, right? So for them, if they are like rushing a transaction between one exchange and another, it doesn't really help them for their transaction to go on the main chain because they're going from trusting exchange A to a trusting exchange B with custody, right? So to their point of view, for that to go on the main chain, it doesn't really help them, right? And then the main chain, there are obviously things where you really want the main chain because you want really strong censorship resistance, you want really secure cold storage, or you're moving larger amounts of money, or you just prefer it, right? So I think we'll see even more optionality evolve and optimization of those layers. So I think another approach, which I personally talked to people who were interested to try larger blocks, was to, and a few people have talked about this, Paul Stork talked about it as well, is to make a sidechain that is making this trade-off that people can opt into. So, and I think that's something that is much more permissionless because people can opt into the sidechain and they can take the existing open source software and build another sidechain. And so it was technically more complicated, of course, and the technology wasn't as mature enough as to do that a couple of years ago. Otherwise, maybe we would have had a big block sidechain instead of forks with different trade-offs. But it could still happen, right? So we could still make one of those using the tech.
Right.
And so, I have sympathies with both views, basically, because it's a trade-off. And,
which way do you think it's going to go?
I mean, for the short term, it looks like Lightning is progressing. And so and like things like Liquid, and there are other sidechains like Rootstock's RSK sidechain, and Paul Stort's is working on Drive Chains, which is another sidechain. So I see the kind of extra capacity appearing on sidechains, which allows each kind of layer or module to focus on doing what it does best, right? So you could say, if you were to significantly increase the main chain, and if it's just a small increase, it doesn't make that much difference because there are billions of people in the world who could use it, right? So from their point of view, it might be better if the main chain increases, a little bit, or the other direction is making more compact or efficient transactions, which is also happening, right? There are like Schnorr signatures allow aggregation, slightly smaller signatures, and Taproot also allows more of the contract to be not disclosed, so it's safe space. And so you see like more transactions being squeezed into the same space. And so then it's interesting if the Bitcoin main chain is optimized for one use case and Lightning for another use case and the layer 2 for trading use cases, then for the traders, they want like faster settlement because they're trying to do op trading. For the main chain, maybe we can optimize for increased security, increased privacy, increased fungibility. So it'd be very nice to see more privacy in Bitcoin too, because there are people doing analysis and it's not as private as it could be. And of course, Lightning has some benefits for privacy too, because it has onion routing, and it only writes back to the chain when people close channels the netted result, so it may not see some of the intermediate transactions, right? So if they never go on a chain and they're encrypted between users, then there are much fewer people that know about this transaction. Right. So that's it's a benefit too.
So with I guess the right now there's a contention that there's block halvenings happening, and then mining rewards obviously going down, but then transaction fees are supposed to be the place that cover that new cost to mine Bitcoin. Do you think that the transaction costs will cover the mining cost in the future?
It's an interesting question. People certainly hope so because they want security, but I think there are also kind of auxiliary things that could be done. So, the protocol as it is today is improving over time, and for the moment there's lots of subsidy, right? The amount of new Bitcoins being mined at the current price creates quite a lot of ongoing new value denominated in dollars to secure the chain. But in the further future, that could be lower. And once, if let's say Bitcoin is much more fully adopted in 20 years' time, there's 4 or 5 more halvenings. The reward could be lower in dollar terms than today, and that if that got very low, you could get a situation where it becomes profitable for miners to kind of fee snipe. So to if there aren't many new transactions that are paying enough to try and mine to reorganize previous blocks and take fees, for example. So then there may be some technologies that could be developed to average the fees over time. And there's also a feature actually in some of the wallets to make transactions only valid after the current height. Excuse me. So basically they use the nlock feature so that the transaction is only valid in this current block or later ones. So if a miner tried to go back a step, the transaction wouldn't be valid yet, so you couldn't claim a fee for it. So it's a kind of way to push things in a forward direction, right? And another thing that might be interesting, which came up during the reorganization discussion from Binance. There was a temporary discussion that kind of faded about, there's a hack.
Reorganize it again.
Could we get it back? And the answer seems to be not really. That's too difficult and there's too many side effects. But something that a number of people thought about is that you could put into the firmware of the miners that the mining firmware itself would refuse to mine at lower block heights. So even when there is if you're mining on the chain and you get orphaned because for a race condition that by chance somebody else found along the chain, you won't switch to the other chain unless it's longer. So it's a kind of invariant almost, right? That the mining hardware never sees the block height go backwards. So you could add that as a rule almost, or it's something enforced. You can't add it as a consensus rule because the network doesn't know, doesn't have synchronized view of the network. You could add it as a local rule in a mining firmware or even in the mining ASIC. And that would basically provide an additional kind of security guarantee of the finality of transactions, even if the reward was lower, because you'd know to censor or undo a transaction once it's done. You have to throw the miners away and build new ones, which is slow and expensive. Right? So there's another kind of economic cost.
So I guess So do you think? So coming back to it, with the fees, how do you see that sort of playing out? Do you think there'll be so many transactions, if there'll be enough fees to pay, or then the side chains will take some of that, or how do you sort of see the world of Bitcoin? And I'd say after a few more halvenings.
Well, I think. Ultimately, if the incentives are there, that people are deriving value from using Bitcoin, there should be ways for businesses to, and traders and users to pay for the service that the Bitcoin fabric is providing. Yes. So you see it with Lightning where, the Lightning transaction fees, they go to the Lightning routing nodes. But there's a way for Lightning to pay for its dependence on the Bitcoin main chain, because when you open and close transactions, you pay. So maybe the Lightning transaction fees will be very low, but then they might pay a bit of a bigger fee to set up a channel or close a channel. And when they're opening and closing channels, they're competing with main chain channels, which are doing cold storage or sensitive resistant larger payments. And similarly for the side chains, they have to move coins in and out between the Bitcoin and the trading side chain. Because when people have done trading, they want to do long-term storage. They really want to do that on the Bitcoin chain. So again, there's a reason to pay fees to get that service. So I think everything that happens above on different layers ends up paying main chain fees. And another kind of more indirect way that people can pay is they can mine. And so you can see that if you were an exchange, some exchanges are pretty profitable businesses, right? Bitfinex had their recent banking problem, and it was mentioned that they had $400 million profit in the previous year, to show that it's a very sizable business that can be sustainable. And there are many exchanges in this kind of scale, right? And Bitfinex is one of the bigger exchanges, but there are other in the same ballpark. And there are other people using Bitcoin for merchants, payment processors, miners who are benefiting from Bitcoin. And ultimately, if Bitcoin wasn't secure, their business would not exist, right? And so it could make sense to them to pay kind of network fees, not by fees, but in the sense of buying 1% of miners or 0.5% of miners and operating it. And so potentially, even if that wasn't profitable, they could do that.
To keep it going.
To keep it going, yeah. And you could see like a very loose analogy in the way people use the internet. So there are sort of peering arrangements. So like you or I, when we buy an internet, we have to pay on a monthly basis for a subscription. But at the fabric level, there are peering arrangements between companies. So there could be a way for businesses to basically contribute to the security of the network as a cost of business, basically. And
makes sense.
Maybe another type of economic participant that has an interest in the security of the network is people who are holding Bitcoin as an investment. So I would say it would be, if you look at a Bitcoin market cap versus the dollar value to buy the equipment in a network that's mining, I think it would take like 1% or less of the investment to buy all the miners, right? So you could say, well, if somebody has $10,000 investment in Bitcoin, maybe they can afford $100 investment in mining, for example, right? And that would be to protect their Bitcoin investment. So if enough people did mining for different reasons, then you have decentralization. So it's not just about like how much there is in the economic incentive, but it's the alignment of economic incentives and honesty, right? So if you have people who are incentivized to see Bitcoin be secure in the sense of not doing reorganizations that undo transactions and things like that, another way for it to be the case is if it's heavily decentralized. And most, 2/3 of them are very honest and don't change the software to do malicious things, and just run it because they want to rely on it for their business or for their savings and things like that. So more decentralization can, I think, tolerate lower direct profitability from mining.
Makes sense. So with Blockstream, do you guys commit code to actual Bitcoin? How does that work?
So there are, I think,
who presses the button to it goes in?
It's organized as a number of open source projects are. So there's a GitHub, and there are maintainers, and then there's a review process. So the maintainer's job is not in a decision-making capacity, it's in a kind of janitorial capacity. So, they basically review process. So somebody will propose some code, and then if enough people who are known to be experts in the code review it and test it and say, yeah, I've tested it and it's good. And you can see these, and if you go look on the GitHub about people saying ACK or untested ACK, which UT ACK, they haven't tested it yet. And then the maintainer's job, and I'm not sure, there's half a dozen or so maintainers, their job is to look at the ACKs that it's been tested and it's good to include, and then they'll press the button basically. But they're not supposed to just press the button because they feel like it or because they like it. And if they actually did that, it would be a political controversy, and probably they would lose their administrative privilege, or they'd move to another repository or something. So it's actually involves this multiple testing setup where you want multiple people to review it because it's very security critical, and one individual, even who's quite skilled, can make a mistake.
Sure.
Just like, thought about it wrong. Oh, like, I'm glad you looked at it because you found a problem I missed, kind of thing, right?
Does someone actually press the button? Like, or is it one person or two people, or like when it?
Yeah, I think at the moment, due to the technical mechanisms, GitHub has it's one person. But I'm not sure. I'm not like actively involved in coding, but I think there was some discussion about having like multi-signature for it, but GitHub itself doesn't provide that mechanism. But there's another kind of follow-on part of it, which is, okay, people are checking in code. Eventually, there's a release, and then they have Gitian builds, so deterministic builds. So basically, you want to convert the source code into a binary, and you want to make sure that the binary is the right binary. Somebody could copy the source code and put something malicious in it and say, yeah, this is a binary, and you wouldn't know. And so compiling usually involves some randomness. So if you compile the same code twice, you'll get a different binary in some areas. So they've modified the Gitian system, artificially forces it deterministic. So if you compile the same code twice, you get the same binary. And so they use that process, and then multiple independent people take the release code, compile binaries, and use checksums to check the binaries are the same, and then they'll sign the binaries. So it's the kind of last step in the release process. So at Blockstream, we have one person working full-time on Bitcoin, which is Peter Whelan, and he has a contract that says literally a legal contract that says Blockstream is not allowed to tell him what to do with Bitcoin, basically. So he's like independent, and the reason we did that is when we were getting our first funding, we were, you got to bear in mind Blockstream is kind of started by Bitcoin developers and protocol people, right? So we saw this kind of risk, and we're like, well, we don't want, if the company is sold in like 5 or 10 years' time, for new managers to think that they can tell people what to do, and Bitcoin should be an independent, neutral thing. So we were able to get the investors to agree to put this contract for the co-founders. So so here's this kind of legal protection, and we have some other developers who do it to contribute, but like in their own time mostly, or like in a not full time anyway. Yeah, and there are a lot of there are more independent developers and more diversity of developers now than there was 4 years ago when we started. There's like several hundred. If you look at a Bitcoin release, there's usually like over 100 people in the contributions list.
Right.
Obviously, some of them contribute more than others.
Right.
But
and so the source code gets committed, then the binary gets generated, and then then someone needs to go, yes, that binary is okay, and that's what a collection of people do.
Yeah. So the idea is that multiple people check that it's the same binary, and then they do a PGP signature on the, there's like signed binaries for all the platforms.
And who does that?
I think probably are multiple signatures on it, but Vladimir is one of the people that signs it as one of the maintainers.
Brilliant. Adam, thank you so much for joining us on the Daily Exchange. It was very enlightening, and the future direction of Bitcoin.
Yeah,
appreciate it. All right, guys, that is Adam Beck from Blockstream joining us. We'll see you guys later. Yeah.